So hi everyone, my name is Kakkala, and today we'll be here for DevOps in detail sessions. As a part of this, we'll cover every tool in details. Let's say at the beginning of we started with Docker. Before this session, we started with something like a Docker basics, Dockerfile, and Docker compose file. And here, what I was planning to do is instead of going in detail, maybe I could take up Docker interview questions and where we will discuss the topics and even understand the concepts. So that's where instead of going a topic wise, maybe I changed a shift in a content again in this DevOps in detail sessions. Where we'll go through interview questions, which makes our things easier to understand the concepts and also a preparation for interview. And this session, since it will be uploaded in my YouTube channel, and my YouTube is diversified with a lot of other content like finance, lyrics, travel. So I'll share screen to show how things work here in Saragakala as well. All you have to do is okay. Remember my name, Saragakala, and you just have to search in Google, and you'll have my website, LinkedIn, YouTube. And here in YouTube, everything is separated by playlist. This session would be uploaded in DevOps in detail with Saragakala. And before coming to this session, in the first session, in day one, we had discussed about Dockerfile, Docker basics, and how Docker existed and how Docker helps in monolithic and microservice architecture. So, if you're watching it on YouTube and before this, I suggest watch this first. And yes, before yes, fine. Maybe we could get into today's session. And today's session, I don't think maybe this would be let's say a combination because I had prepared only few interview questions, and maybe in the next weekend I'll prepare all the other interview questions that Docker has to offer, and we'll club those sessions and only then I'll upload. So these are some basic questions, but you will be understanding concepts here. So here in the Docker view interview questions, first thing, let's say, if someone asks what's Docker architecture, before, if someone asks what is Docker architecture, we'll understand how Docker works here. Let's say, maybe, okay, fine. Let's say here I'm opening Docker Hub just to have a visualization. And here images are nothing but your OS. Let's say something like your Windows 7 is a OS, like Mac OS is a OS, and only for your OS to work, it has to be deployed somewhere. And that deployment here is container. Here, let's say my laptop here is a container, and the image, this is a Mac OS, it's actually image. So what it does, let's say if I run a command here, since it's Docker already installed, maybe let's go to my terminal. What I'm doing is I'm running Docker run Nginx. Yeah. So if you see, it did not find the image locally, means that OS is not inside my machine. So it pulls the image from Docker Hub, which is actually a Docker registry, which we'll understand slowly as well. As you could see, there is this image called Nginx that formed just now. And because I created Nginx 5 days ago, so it got 5 days ago. So Nginx, and as you could see, this image, it even got the container. So the container, if I do not give the name, it actually picks up the name it wants, a crazy names. And here image. So this container, maybe this laptop, you could think, is running with Nginx image. So after running this command, what happened is what we will understand in this Docker architecture. Let's say the terminal that I opened, you could think of that as Docker CLI. So Docker CLI is nothing but a terminal or a something where you could input your Docker commands. And the Docker commands could be anything like Docker run, and there are other commands as well, which we discussed. As soon as I ran the Docker run Nginx command, what happened is Docker CLI starts communicating with REST API. And REST API is nothing but a communication key between Docker CLI and Docker daemon. And Docker daemon or Docker daemon, let's say, and another thing I forgot, there are only three components here in architecture: Docker CLI, Docker host, and Docker registry. And in Docker CLI is nothing but the terminal that I opened, or anywhere you input that terminal, that goes as a Docker CLI. And as soon as I ran the command Docker run Nginx, it goes for REST API. And REST API actually acts as a communication between Docker daemon and Docker's ELI. So this Docker daemon says like the Docker CLI has given a command something like Docker run Nginx, and this Docker daemon goes for container D and tells there is actually a command that is being done like Docker run Nginx, and this container D is responsible to turning up our containers. And this container ID, what it does, it actually checks whether the image is existing locally or not. Let's say, since now the image we had this locally, it doesn't pull from, let's say, it doesn't pull again because like the image exists locally. Let me stop this. Now, if I give something like Docker run Nginx again, because let me delete this container first. And because the image, like we already got it locally, it doesn't actually fetch it from. Okay, as you could see, it actually already got it or already got the container up, like instead of pulling the image from the registry because the image existed locally. Means like before in the previous command, we had downloaded it. So that's what it happened. And like what if the image doesn't exist locally? It goes for Docker registry. Docker registry are nothing but like there are a lot of other tools like Harbor, and like the famous one was Docker Hub. So it checks the images here, let's say Nginx. So it actually pulls, not this, sorry, the official Docker image. So it actually pulls the OS from here and it actually runs the container up there. So based on that, like it pulls the, like it takes the container, I mean like the image from Docker registry and turns up the container. That's the process of containerd. So, like to put it simply, what Docker architecture is, when you run Docker CLI, it communicates through REST API. REST API goes for Docker daemon, and Docker daemon communicates with containerd, a service in Docker, and a containerd. It checks whether the image exists locally. If not, it goes for Docker registry, and then turn up our container. Okay, till here it's clear, right? And Docker host is nothing but a machine where Docker is installed. So my laptop here, my Mac machine here is actually a Docker host itself because I installed Docker inside it. Uh, is Docker architecture clear? Yes, Vishnu.
Yes, yes.
Okay, fine.
One thing, it
Yeah,
was recording.
yeah, I'm recording it. Why? What happened?
Yeah, yeah, just confirmation. I have.
Now, if I'm not recording, why would I would take the session? Fine. So here, like as you see, the Docker daemon is the one that manages containers. Containers are nothing but, as I said, like a kind of mission or something. Maybe let's say like you have a phone, and your phone is your container, and like you could deploy your Android OS in it. So your phone is completely a container, to put it simply, and only when you deploy your Android OS, only then your machine works. So that's container. And volumes are nothing but, let's say, if we take the example of phone itself, it's your memory card. Maybe now no one is using, before it's memory card. And images are nothing but like your Android OS itself. Let's say maybe even in Android we have OS like Pi, Raspberry, and other things. And networks, like we will discuss this as well. And API requests, as we said, API is nothing but, let's say, a communication between Docker CLI and Docker daemon. And yes, and like we'll go for next. What is container lifecycle? As I said, container is nothing but uh, kind of dabba, kind of like an empty box, and it only works when you have an OS installed in it. So let's say like we'll understand container lifecycle itself. Just like we turned up container first. If I'm giving Docker create Nginx, what happens here? Let's go for my Docker hub again. Ah, yes, and like there is one more thing here in Docker. Like since this container is running with Nginx image, if I try to delete this image, it doesn't happen. Deletion failed because container is running with this, because some container is using this OS, and till the container is deleted, we'll not be able to delete the image. So let's say I deleted this container and the images, let's say, yes, like I'm recreating again. So from the terminal, I actually gave Docker create Nginx. So I'm actually explaining container lifecycle with the commands here. So as you could see, because I deleted image, it pulls up the image again. The same process goes. It goes for container ID. It actually checks whether it's not in local. It goes for Docker Hub. Image came up, but as you could see, the image came. Now if I go for container, it created container, but it's not running the container. So as you could see, the container is not running. So for it to run the container, what I will do is like Docker start, and whatever the container ID is, either you could give the full container ID or only the base, like first three letters, 267. So as you could see, the container started. So the Docker start. And another thing, like if I want to stop the container, it's just again the same command, Docker stop 267. So it's done. And now let's say there is another command like which we already discussed in previous. I'm deleting the image. Okay, it doesn't delete because the container is there. Hmm. So let's say I gave like Docker run nginx, which is the first command which we did. This actually pulls the image and also starts the container. As you could see, this pulled the image and also started the container. Run is actually a combination, let's say a combination of create plus start. So Docker run command is a combination of it creates the image and also starts the image. And also, like when you give Docker run nginx, you'll not be able to use the terminal because it runs your Docker container here itself. So what I could do is, let's say Docker run minus D stands for detached. Means like I could still use the terminal and my container is still running in the background. As you could see, there is a new container that ran up, and but I'm still able to use the terminal. So minus D stands for detached. That's it. Like this is an important command because like everywhere you go, minus D should be used, else you'll not be able to use the terminal itself. So here, and one thing, let's say, let me go for containers back. And as you could see, this is the container ID. And if I want to stop the container, it's Docker stop. I think like I gave the command already. Okay. Docker stop 1C4. So whatever the process are running inside the container, it actually stops it. But what if, let me start again. But I want the container to be up, but I want the process inside to stop. Let's say stop in the sense like entire process would stop, like your container is stopped and nothing you could do. But what if I want the container to be up, but I want the process inside to stop? This is actually not an useful command, but just to know. Docker pause 1C4, as you could see, the process inside which it is running, it's actually in a paused state. So this is actually paused state. So now to unpause it, Docker unpause 1C4. So this, and if I want to remove the container itself, what I'm doing is like Docker rm 1C4, the container ID, this three letters in the beginning. Okay, the container is running, so it can't remove. So if I want to remove the container, first I'm going to stop it 1C4, and now I'm going to remove the containers, let's say. And if I want to remove both the containers, let's say 1C4 and df00. So it removed all the containers. Now, since the container is removed, I could remove image from the commands. Like this is nginx, right? So I'm going to remove just a command like rmi. This is just remove. Rmi is remove image. I stands for just an image. Remove nginx. So as you could see, the image is even removed. This is about like container life cycle. Clear, right? Like the commands create, run, rm, pause, unpause. So this is kind of like container life cycle you could have. Is it clear? Yes.
Yes,
Uh,
correct.
yeah, and now we'll go for Docker networking and its various types. Like Docker by default, what it happens is like by default there are like three networks that Docker creates. Maybe yes. Okay, fine. Docker network ls. As you could see, there are three networks, like one is bridge, one is host, one is null. So let's say like we'll discuss these are created by Docker by default. Now let's say let us run as Nginx image itself, and while running Nginx image, where is this command? Okay. Yeah, I'm going to use this command. Now, what I'm actually doing is Nginx by default runs on 80, port 80. So Nginx by default runs on port 80, and here this is my host port. Host port is nothing but my machine, like my Mac here is a host here, because like inside my Mac, I'm running this Docker. My Mac acts as a host here, and here 80 is a container, and minus p is nothing but port, and this is nothing but like port mapping. If I give like docker run nginx, it actually runs the container and it assigns container an IP address. But for me to access like whatever the container is running, for me to access the container on my host, I had to use port mapping. As you could see, to expose to the host, like host is nothing but my app, I had to use port mapping. Let me give this command itself. So nginx, like nginx, simply saying like maybe like I could just run the command and show. Where's this terminal? Okay, unable to find. Okay, fine. And as I said, minus d is detached, minus p is like port mapping. And as you could see, like Nginx came up, and here name is nothing but container name. Because as we said earlier, like if you do not give any name, it takes some any random name, Docker assigns random name. And here Nginx is nothing but the image. So it pulled the image. It now named the container as my Nginx. And as you could see, port mapping is 8080. It's nothing but inside your container, let's say inside your container, Nginx is running on port 80. Maybe I'd explained this before as well. Let's say maybe I could just give a quick diagram itself. So this is our host mission, like which is my Mac OS here. So this is my host mission here, and inside the Docker is running. Let's say inside Docker is running. It's actually called the Docker engine, and inside Docker engine, like there are like containers running, and let's say. mm, I don't think the container is there. Okay, fine. Let's like assume this. Like inside Docker, we had turned up like Nginx image, and Nginx image like it's accessible on Docker container on port 80. So here, like if I want to access this like container on my host, like on my Mac machine, what I had to do is I somehow have to access this port 80, and I'm accessing in my host machine via port 8080. I exposed it here. As you could see here, I exposed on my host port 8080 on a container port 80. So if I go for like localhost 8080, as you could see, welcome to Nginx. Like we are able to get the Nginx. So this is how like Docker bridge network works, where every container has its own IP and can communicate with each other. And by default, when you raise an image or like run a container, Docker by default assigns it as a bridge network itself. And now let's go for the other network like host is nothing but, let's say, because here in Mac, like it was said, like in Mac or Windows, this command doesn't work fine, but this command works like when you have a Linux machine. So let's say here's terminal, where's my terminal? Okay, so as you could see, yes. Okay, this is another. As you could see, my port is not happening. What happens here is, let's say, mm, inside this, let's say inside like let's say what happens in network is, since in bridge it has a different IP, so the container has a different IP. Let's say it should be like 172 dot 3 dot something. So it has a different IP. But here, when you are using Docker network host is nothing but your Mac OS itself. Whatever the IP that your host has, same IP is assigned to that container. Let's say this IP is like host IP is 172.32. One second. 32.24.1. So here as well, the IP would be 172.32.22.1. The container doesn't get a different IP, it gets the same IP as the host. So there is no port mapping required, like whatever, like container port is exposed in localhost 80. So I could also go for localhost 80. This doesn't work actually now, but I'm saying. So this is something like the network has works. And this is on like host because the network spelling itself says it's like host. And none is nothing but like your container doesn't have communication with anything. Let's say maybe there's like no IP address assigned to to your container. There is no internet, like there is something going on, but you'll not be able to access it. Neither your local host, just like I showed, like localhost 8080, it can't access. Maybe like these three I could give example to make it more easier. Let's say like you have a friends in an apartment, and like that apartment you could think of like my host itself here, and the containers you could think like your friends inside that building. Let's say how bridge works is, and like you have a friends inside that building and you have a key to access. Key is nothing but your port mapping, and you could go and meet your friends there. So that's bridge. And like if you want to see your friends, you have a key, you could see whenever you want. Host is nothing but like your you don't need a key because like your friends are already at the balcony, so you could just wave hi to them or talk to them and communicate with them. You don't need to enter inside the building itself. That's host. And none is nothing but your friends were locked inside the apartment building and you don't know what's the door number, and you don't know like nothing, and you can't even communicate with them, but you know they exist there. That's it, like the three differences between, just on a normal basic example that I gave here. And overlay network is nothing but, let's say like you have a two apartment buildings, and two apartment buildings like where you have like here a friend and here a friend, and you want both of them to communicate with each other. That's when you set up an overlay network. And like this overlay network is mostly used via Docker Swarm, and Docker Swarm is not being mostly used, and because like it's just being replaced with Kubernetes, and like we'll discuss on Kubernetes as well. And Macmillan network is nothing but like your container uh, acts as a separate device itself. Maybe if you have an Android, like there is this thing called like secondary space. And like when you turn on secondary space, you have your phone inside it, but the secondary space acts completely as a new phone. And like there would be like when you buy a new phone, the secondary space acts as a complete new phone. So that's how it is. Like when you use Macula network, like it acts as like not inside host or container. Container is a different physical device itself. So that's how Macula network works. So till here it's clear, right? Yes.
Yes, sir.
Yeah, I think maybe like we'll not take a picture today because I put oil on my head. Oh shit. Yeah, so everyone, welcome back. Let me share my screen. Okay. In the last session of Docker, like we had discussed only three questions where we had went through like how it's Docker architecture. We had discussed like how Docker works using like Docker daemon and everything, and like how the Docker CLI works and everything. The same way, like we had discussed like what's container lifecycle and like what's Docker networking and its various types. I think like we had discussed only three questions. And here, like what, like we'll just go on a scenario base. Like what is Dockerfile and Docker Compose file? Like to put it in a simple words, like Dockerfile is nothing but a step-by-step instructions that you would give for our image to be formed. To build a container image. This is like we clearly discussed about this, like during our first Docker session. So I'm not repeating. Like let's say like this would be the Docker file, like from work directory, copy, run, and everything. And using this, like we had formed an in the image, like we had built an image, like we had built a React app, and like we had deployed it in Nginx image. And each thing here is called a layer. Here from is just a basic layer, work directory is a layer, copy is a layer, run is a layer. I'll explain why I'm actually telling this in like shortly as well. And here even expose is even a layer. Like for each line that you write in Docker file, it acts as a layer. So the number of layers, let's say, if once a layer is built, and like if you are actually giving a Docker build again, like Docker has it as a cache. So let's say if this layer is already built, Docker keeps it in temporary cache and uses this layer again instead of forming a new layer. This way, if you build images like a repeatedly with the same base image, like Docker builds it faster. Only for the first time it takes time, and the remaining times it actually builds, it actually keeps the layers in cache more like a temporary memory and builds it from there. So that's on Dockerfile. Like it's just a step-by-step instructions to form a container image. And what's Docker Compose file? Even Docker Compose file we had used in Apache Kafka project that we had done. Here, Docker Compose file, like where you have a different images to run together. Let's say like three or four containers you could run together. Let's say like this is Docker Compose file. In this, I had specified this image, and also I had specified this image. So it's like let's say you have a three-tier application. You could use Docker Compose file, keep every image there, and like run that application. Let's say like front end, back end, and DB, everything in the same file. Instead of having like three Docker files, you could have one Docker Compose file that can have all the containers. That's the only difference. Remaining the working is the same. Only the commands would differ. The Docker Compose up and everything. And here, like as I was discussing, different layers in Docker. As I said, the first line is a base image layer, and the second is metadata layer. Like these are like not mandatory. Like metadata layers are like not mandatory. It's just like labels to know for us. And like there are only few like layers that could be mandatory for us to form an image. Some like copy image and run container image. You could say like even this could be a port layer image and the mount image and everything. All these layers are not mandatory, but like each line acts as a different layer. Maybe I could show from Docker desktop itself. Here, if I go for images, I go for Nginx. As you could see, there are 18 layers here. Like each line is actually a layer here, as I said. So, and like if I give start analysis, this goes for this, let's say Debian is a base image, and on top of Debian, the Nginx is built, and everything else like Docker entry point, and everything it was formed using layers. And where you could see this, because like I had pulled this from Docker Hub, you could check this from, let's say, Docker Hub itself. Yeah, Docker official image. Mm, 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 Not this. There is a kind of like repo I could go to search this. Mm, 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 mm. Is this? Yeah. Where's I think like Docker Debian template, Docker file. I'm not sure like what exact layer it's using. Yeah, this could be this env nginx version, env ngs, env depk, and run. Okay, let me see. Mm, yeah, this is the same Docker file that it is using. So here each line acts as a layer. So that's like Docker layering. That just like your Docker file, like you could say, like whatever the lines are there, like each line acts as a layer here. I'm not just going on to demo here because like we had done that in the previous session, so that's why I'm not going there. And here even I explain like what's the difference between add, copy, run, CMD, and entry point. Run is nothing but like your basic command to run. Let's say like whatever commands you want to run inside your container. Let's say inside your Linux machine, uh, you could say something like let's say like install Node.js or something. Whatever commands you run inside your terminal, you could use run there. And CMD is nothing but your start point. Like whenever the container is up, like what you want to run, that's where like we run cmd. And here the difference between cmd and entry point is, let's say like you have 3 to 4 cmd lines. By default Docker picks up like whatever is the last cmd line. Entry point is nothing but a stricter startup, like instead of using cmd you could also use entry point. Entry point is like when your container start, it has to start compulsory. And here, like what's the difference between add and copy? Add is something where we could actually download URLs as well, and also like unzip tar files as well. Copy is just like your copy file. So that's the only difference there. Add also works as copy. Yes. Yeah. And here, as it see, like how to reduce your Docker file size. Simply like whatever the base image is there. Let's say maybe here itself. Where the GitHub repo. Let me take this. So instead of using Debian, like Alpine is actually a light image here. So instead of using like Debian image, even Alpine image can actually can reduce your image size. Maybe here I could say, like as you could see here, Nginx image is 255 MB. Apache Kafka, which has like Apache installed, like Tomcat installed and Kafka installed, it might have like a big size MB. So as you could see, like based on like what base size image you're choosing, like it could reduce your image size. So first thing, and other thing is here to combine the run commands. Let's say like this is what actually I had done in my previous company as well to reduce Docker file size. So as you could see, like this forms like three layers, one, two, three layers is like a bit of memory. So instead of that, I could combine all the run commands into one and form a single layer to reduce memory. Actually, this is what been done here as well. As you could see, they gave a single run command and had run everything as like end to form just a single layer, and there was no other command here, only run. So a single run, like instead of like if we had given like number of layers, it might have increased Docker file size as well. That's one thing to reduce Docker size. This is actually something that I had done practically in my previous company, and it reduced as well. And here like you could use Docker ignore file to copy unnecessary file. Here just like dot get ignore. Maybe I had done this, I guess. Mm, If you remember, like last time we were discussing about Gym per Day app, there one thing that I did was I had not this. Okay, here I had copied like node modules folder, like which is actually an unnecessary file here. So it actually creates a lot of memory, like in my GitHub. The same way, this is not necessary. Like when I give build file, like npm run build, this node modules file forms automatically. So it's just like unnecessary and a waste of space for me. So like you could ignore these files because like even while container building, we'll actually build the file. Let's say as you could see, like we are here building the file again. Where is this? Yeah, when I give npm install here, like it brings the node modules files there. So it's a waste of time for me to copy node modules file again, and even .get the logs, like these are unnecessary file that increase the Docker image size. So this is something unnecessary. And here like use multiple stage build. This is what like we did in our last session as well, in the first session. So where if you could see, these are like two steps. Like first step is like we had taken a React app and we had formed build, and we had used the same build there from the previous one. Like from the step one, we had used the previous build and deployed it in our Nginx. So this is sorry, deployed it in our Node app. So like once this build is formed, this deletes this container here, and this keeps only this container. Like this container has code, package.json files and everything, and has the build folder as well. And here this container has only build folder and nothing else. Like this build folder has the dependencies and the app code for us to work, and nothing like a GitHub repository code and everything. So this actually saves memory as well. So this is a kind of a multiple stage build that's formed. And here is the best part. Like now we'll go for a demo. Till here everything is clear, right? Like because I just gave on a top up because these were discussed in last sessions as well. So that's why I did not.
This clear, Sagar.
Yeah. Uh, okay. And now, like how to debug Docker container. Let's say, like if you are running an app, maybe like let's run a container. I'm running Nginx image. Mm, okay. Now I could see my container, compassionate something. So let's say like my app is not working. What I'll do first, like as a debugging steps, like a troubleshooting steps. Let's say 1 second. Why is the CA not working? Okay. First thing is I'll check whether anything like whether something is shut down. What we check if the container is running or not. Okay, as you can see, the container is running. So PSA, it's running. The container is running. Next thing is like I'll be checking like logs of it. If the container is running, like what's happening? This is actually a basic troubleshooting that we'll do. Uh, Okay, okay, sorry, my bad. It should be 148. Hmm. As you could see, the process is running. If there is anything like Nginx is stopped or something, you'll be able to observe it in the logs itself. And sometimes, like there is a kind of thing like where your application is running, but it's not able to get the resource. Let's say a lot of times it happens in DevOps and Linux world as well. So your memory gets full, like the server's memory gets full, and the resource it could go for 70% CPU and 80% CPU and something. And at that time you need to know like what's the status of this right now, so that like you could reduce the CPU or increase the containers or do something. That's where like we will use Docker stats. Even you could go for container ID or container name. Like what's container name here? Yeah, compassionate bins. Oh, my bad. Compassionate bins. Hmm. As you could see, CPU is 0% because like currently now no work is going on inside CPU. So that's where like CPU is 0 and memory usage is 19 out of 7 GB. So everything looks normal. So this is one. And another thing is actually you could like to check the configuration, like whether you had like given the correct one or correct image, or is it like taking a wrong image or something. Actually, there was an incident like where like we formed an ECR image and the tag did not go right, and as a part of it like our application went down. And for that like even if the tag is not right, your image won't be formed and container won't be formed. And like even if the container is formed, for us to check the image we go for docker inspect. Is actually a big command that we use every time to like check what image it's using and like what configuration it has. To put it simply, a configuration of the container is like what you'll get here, and also like what IP address the container has and everything you get here. 1 second. Yeah, here is like image URL that is formed and the Docker Nginx Debian, the one thing the URL which I showed you before. Where's the IP address? Yeah, since it's Nginx, port 80 is exposed. Mm, Wait, I can't find IP here. It should be somewhere. Yeah, here is the IP address. So this is the IP address of the container. So you'll have like everything that you required about this container that's running using Docker inspect. So it's more like your configuration. That's it. And one more thing. Okay. And if you want to log into this container, it's Docker exec minus IT. Like if you want to troubleshoot by going inside the container. So it's 148 or compassionate bins anything 148. Let me give her 148. Yeah, slash bin slash bash. Yeah, as you could see, now I'm inside this container. So if I want to come out of the container, just exit. Yes. And as you could see in the DevOps world, you might know, let's say, there is a famous thing that we all started DevOps with. Let's say dev and ops were actually fighting with each other, and like it works on my mission, and like ops says it doesn't work on my mission. What it actually does is like dev actually builds a Docker image and sends it to ops, and like ops downloaded that image and also like checks like the application is working perfectly fine. And now it's Kubernetes and everything. And before, like how we used to do it is, let's say, okay, let me clear the screen. Let me create a new image for it. I just want to give, and here I'm running this container with image. Here I'm naming it as like my Nginx. So yeah, so I have container my Nginx, and now let's say I had worked something on this container. Like I went inside, I had deployed some applications, and I thought like everything is perfect. And now I want to like be let's assume like I'm a developer guy, and I want to send this like image to ops guy. So what I'll do is here simply like whatever it's running. So I'll form a Docker commit, like whatever is a container name or a container ID. So I'll give my image name and a tag name. And let's say maybe, yeah, Docker commit my Nginx. Like this is the container name that we had specified enough. And image name is something that I want to actually give. So just colon 12.3. I'm just giving colon 12.3. So it formed an image with my container. Let's say I made some changes and this is something. Okay. Okay. This is 1 second. Let me remove the previous one. This is, I was testing just to avoid confusion. Yeah. So this is the latest one that I had built, like my Nginx 12.3. And now what I want to do is like because I formed this image and now I want to send this to my ops guy. So what I'll do is like first I'll like zip this file, just like we compress these files, right? The same way I'm like compressing this file. So what I'm going to do, Docker save minus O. So whatever is the tar file I want to give, let's say I'll give like my nginx dot tar. Like this is the name of zip file that I'm giving, and this is let's say, and this is the image file. Okay, bad. So let's say I had saved this as my nginx.tar file. So from the container, I had actually formed my nginx like .tar file. Like I formed the image and compressed it. Now I'm going to like send this like using VR Teams or something, anything I could like send this file as well. And now let's say, let me remove this file, docker rmi. Okay. Now if I give Docker images. As you could see, this image doesn't exist now. And because like I zipped this file, as you could see, where is this dot tar? Yeah. Okay. This is the previous tar that I did, and this is the now the tar that I did like during this session. So let's say I had sent this file to the ops guy. What he is going to do is like he's going to download this file, and all he'll do is like use docker load command, docker load command, and minus I. What's the image name? It's like my nginx dot tar, and it loaded image. And now I if I give like docker images, as you could see, the image just came back. So this is how like when you form or like take a base image, form a container, like do some changes, your application changes, and compress it, and you could send to any like ops guy or anything you want, and based on that they could test this image. Now if I want to run this image again, it's just like docker run minus d and this image name. Clear here, right? Like how we are saving container as image and like exchanging files. Yes or no?
Yeah, it's clear,
Yes,
sir.
sir.
Okay. Like we'll go for Docker volumes here. Or maybe this is not necessary now. Okay. Hmm. And here comes the volumes. Where is this? Okay. Here comes volumes. Volumes are nothing but, let's say, like when you have a container, if I delete this container, whatever data is there inside my container, it's lost. So I don't have my data again. But what if I could create a volume? And when I create the volume is associated with this container. I could actually, like even if the container is deleted, since my volume is there and my data is safe, I could use the same data to another container as well. Like we'll check it practically. And let's say like this is mostly used for databases. Maybe here we're not attaching databases. Let's say I'm creating a volume. Okay, here, Docker volume create. I'm just naming it as my volume. So this is, you could think of it like your hard disk for your laptop, and you could just remove this hard disk and like keep it for a different laptop, and you have the same data what's there in hard disk as well. So now I'm actually turning up a container, let's say, and for me to attach, yeah, I could actually check whatever the volumes are there. Since like we are using Docker desktop, it's easy for us to monitor, but like we'll be using commands here. And here I'm attaching like whatever the volume that I used, I'm actually attaching this volume to like Nginx image. Here Nginx is image, and slash app slash data is a path inside our container. Maybe I'll show this practically how this works. Let's say, so this is actually now we got a container that formed with this volume. Let's say, so this is this container. As I said, let's log into this container A1F. Okay. So, as we learned previously, Docker ps minus a, okay, Docker exec minus it a1f slash bin slash bash. As you know, like our volume is associated with slash app slash data. Like whatever is there, like inside this, it gets into my volume. So I'm just going into cd slash app cd slash data, and here, like there is nothing. So I'm going to create just a test file. Mm, Yeah, I created a text file here now, like hello.txt, and I'm just exiting this. I didn't do anything. So now what I'm going to do is like I went into app data, and app data is associated with my volumes. And now what I'm going to do is I'm going to delete this. As you could see, like before deleting, like the name is different and the container ID is different. So here I'm actually deleting, and now I'm going to form a different, again, a different container. So now it formed a new container. But what I did here is I associated the same volume again. The previous volume, my volume, I attached it to the new container. So now if I go to like Docker, mm, 68a slash bin slash bash. Now, as you could see, hello.txt is there in our new container. And how did it happen? Because we had attached this volume to the new container. You could attach the same volume to any number of containers you want, and you'll have the same data here. Till here, it's clear, right?
Yes, yes.
Yeah, and one more thing, let me delete. And now, like instead of having volumes, let's say, like this volume is something, it's for Docker, right? And you don't want volumes to be there. And you want your host path. Let's say I want to have my host path. Host path is nothing but the one inside my MacBook. So here I'm going to create a directory saying that, let's say instead of using like Docker volumes, I want to have like whatever is there like inside my Mac, like I want all the data to be inside my host machine. Mostly here it's my Mac here. So I created a Docker data. So what I'm going to do here is I'm going to run new container and I'm going to say like the path, like this is my host path. And this is again the container path, like inside the container. And I'm running again the images Nginx because I just want to make things easier. So I'm going for Nginx image itself. So this formed slash app slash data in Nginx. Now I'm going to again, let's say, remember like this path, like this, like Docker data is inside my Mac machine. So if I go for like cd Docker data, there's nothing here. Now what I'm going to do is like Docker exec minus it. It is like iteration mode and py c3 slash bin slash bath and the container path is again like slash app slash data. Just like forming something file here like so I formed a file here. Now I'm just like exiting the container. It's still in Docker data. As you could see in my Docker data, like this is inside my Mac, I exited the container. It formed sagar.txt, the same volume. That's where, sorry, it's cat, right? Yeah. Hello, this is Batman. The same one that I formed inside the container. So this way you could attach your host data. This is called like mount binding. Either you could use Docker volumes or either you could use mount binding to keep your data persistent from the container. Clear, right? Yes.
Bro, what is the difference between volume and the host part?
Host path is nothing but like inside my local machine. Docker volume is nothing but inside, let's say, a hard disk, a kind of thing. Like where you are forming an external hard disk and keeping it there. Host is like this is something. It's my machine's data. Like it's completely my Mac data that I'm associating with it. That's it. Here Docker volumes you could transfer, but here host data is something. It stays only in my machine. That's it. Clear? Yes? No?
Yeah, clear, Sagar.
Okay,
Yeah,
fine.
yeah, it's clear.
1 second. Okay, let me. Okay, and like to inspect these volumes, let's say you could actually go for same thing, Docker volume inspect. Yeah, maybe here I could tell, like as you could see here in Docker volumes, my mount point is like var lib Docker volumes and my volume and slash data. But here, like if I'm using my host path, my mount data is my local path. So user Sagar Docker data is my local path. Like this is something provided by Docker, the host path for volumes. And here this is something that I decide like where in like which path my data should exist inside my local or host. Clear, right? And if I want to delete this volume, mm, it's Docker volume RM, I guess. 1 second. Docker volume RM, my volume. Hmm. Yeah, actually you could use this commands using Docker desktop as well. But just to make things easy, I just this. Yeah, here as well you could create volume and everything is the same instead of commands as well. Clear, right? I think yeah, that's all on the Docker part. I'll stop sharing screen. Stop recording.